In this video, we are going to learn about the least squares regression analysis. Let us visualize the method of approximating the line of best fit. This is the main procedure used in statistics to develop linear model. Let us try to determine the straight line that best fits the points 1, 1, 2, 2, 3, 4, 4, 4, and 5, 6. And all these points are plotted here with an x-axis and a y-axis. And for the data, what we have plotted here, we are trying to fit the line of best fit. So if we are trying to guess the result, maybe let us try the line y equals 0.5 plus x, which is this white line what we are getting, where the slope is 1 and the intercept is 0.5. This seems to be a good choice for the line of best fit. But if we are trying to find the better choice for the line of best fit, let us approximate this to be the line y1 is equivalent to mx1 plus c, where m is the slope and c is the intercept. So when we are trying to get the line of best fit, it looks like the white line what we have here will be the line of best fit, for which the slope is m equal to 1.7 and 1.2 and the intercept is negative 0.2. So the line what we see here, the white line what we see here is the line of best fit. So when we have the line, the set of points given here, we prefer getting guess a line, and then we are trying to fit the line with the point whatever is given. Let us take the next guess. So in this, let us assume that the points are already plotted. 1, 1, 2, 2, 3, 4, 5, 6 and 4, 4 are already plotted. And we know that the line y equal to negative 1.2x minus 0.2 is the line what we got from the previous one. But if we are trying to get a line g equal to 1.2x, which is the red line, that is also a line which is closer to the yellow line. So among these two, the line what we have here is 1.2x minus 0.2, the red one and the yellow one. We would like to know which one is the best fit. So in order to compare these values, with the one what we had earlier and the one what we have now, let us see, we can prepare a table, and then using the table we can guess which is the line of best fit. So we are going to use these three models. The first one what we had, the guess was y equals 0.5 plus x. The second one what we got was 1.2x minus 0.2, which was my model 3, and the other guess was the red line f of x equal to 1.2x. So if I take the values xi and yi here, let us take this first one as xi, the second one as yi, and for these values you can find the value f of xi for the given f of x is 0.5x, and then take the difference between yi and f of xi, take the square of that, sum of the squares. So sum of the square is 1.25 in this case. For the model 2, the sum of square is 1. And for model 3, the same way you are trying to find yi minus fxi the whole squared. So that difference squared is 0.8. So when we compare all these three, the model 1, model 2 and model 3, it looks like the sum of squares of these errors is minimum only in model 3. That is, for the model 3 f of x equal to 1.2x minus 0.2, we get the sum of squares to be the minimum. So that will be the line of best fit. The first one, 0.5x, 5 plus x, was a guess. That is a fit, good fit. 0.12x is a better fit. The best fit will be 1.2x minus 0.2. So, of all the linear models for a given set of points, the model that has the best fit is defined to be the one that minimizes the sum of squared error. So in our case, the minimum sum of squares of these errors is only for model 3, which is f of x equal to 1.2x minus 0.2. So that is the line of best fit. This model is called the least square regression line, and the procedure for finding this least square regression line is called the method of least square. Hope this video was helpful to understand how to find the least square regression line and what is the method of least square regression line. You can guess, you can find a better fit, but all what we need is the line of best fit. The line of best fit will have the sum of squares of error to be the minimum. Hope this video was helpful in understanding what the method of least square is. Thank you for listening and thank you for watching.